800 feet vertical curve with equal legs is provided for a highway crest vertical curve. The grade of the back tangent is 2% and the grade of the forward tangent is a negative 2%. The elevation of the point of vertical intersection, PVI, is 1200 feet. What is the rate of change of grade? And 2, what is the tangent offset at the PVI? I would go ahead right away to the FE handbook and write down a rate of change of grade just to see what are we going to get. Control F, rate of change. And you notice how you are taken to this page, which is under the civil engineering, under the vertical curves, and rate of change is this lowercase r. And on this page, you're also given a formula, which is G2 forward tangent minus G1 back tangent over L. And L is this horizontal distance between PVC and PVT. So let's go ahead and write this formula down. So we have R equals to G2 forward tangent minus G1 back tangent over L. Now let's talk again, what is G2? In the problem, we're given G2 forward tangent negative 2%, 0.02. I'm going to also write down minus 2%. G1 back tangent is 2%, 0.02, or just 2%. And then L, the horizontal distance between PVC and PVT, is 800 feet. Now, when I go back to this formula, I can use these values, or if I want to use the percent values, I have to work with stations instead of feet. So when I have 800 feet, this equals to 8 stations. So now I can go back in my formula and use these values. And it's very important not to mix them up. So here, going back, I'm going to have minus 2 over 8. This is going to give me minus 4 over 8. This equals to minus 0.5. So the correct answer is B. And next question, what is the tangent offset at the PVI? Again, I'm just going to go to the FE handbook and just write down tangent offset at the PVI. Tangent offset. And here we go. We are taken to this page again, and tangent offset at PVI is the capital E. And capital E here, the formula is given as A, lowercase a multiplied by L over 2 squared. And then A, the formula is over here, everything is given. Let's go ahead and write the formula for the tangent offset at PVI, and then we're going to go back and write the formula for A. So E is equal to A multiplied by L over 2 squared. So E is equal to A multiplied by L over 2 squared. And then we have to calculate A. Let's see. A is the parabola constant. There you go. A. And we have the formula over here. So let's write the formula for A as G2 minus G1 over 2L. G2 minus G1 over 2L equals. And as we've discussed in our previous point, G2, we're going to take it as -2. G1 is going to be equal to 2. And L, we're going to work in stations. So L is 800 feet, meaning it is 8 stations. So here we can say -2 minus 2 over 2 multiplied by 8 equals minus 0.25. And now with the A known, let's go back to our formula here. We're going to say minus 0.25 multiplied by L in stations is 8 over 2 squared equals, let's use the calculator, we're going to have 64 over 4 divided, multiplied by minus 0.25. And I get a value for E as -4. So in this case, the correct answer is going to be C. And I just want to point out for the problem today is that even if you don't know what the rate of change of grade is or tangent offset at the PVI is, just go to the FE handbook and do a search, and most likely you are going to find a formula for it. So that's it for today, a very short problem. If you have any questions or concerns, please leave your questions in the comment section below. Otherwise, I'm going to see you next week.